Yeah, good evening, everyone. So, in the last videos, we had a very clear discussion about, I think, linked list, right? So, in that, different types of linked lists are there, like a single linked list, a double linked list. Okay. Next, and after that, circular single linked list. Like that, we have so many types are there. Okay. So, we covered very clearly some basic operations on single linked list. Now, in today's session, we have to start one more linked list, which is nothing but a double linked list. Directly, we have to implement the program on this. Okay. So, double linked list. Okay. Let us go with double linked list implementation. Okay. Sir, anyway, 7th January 2023, that is on Saturday evening, we have class at 7:15 as usual. Okay, so maybe I will take at 7:30. Okay, so 7:30 p.m. to 9:30 p.m. 2 hours I am going to take. Okay, 2 hours I am going to take for um, covering string handling. Okay, okay. So you people have to attend at 7:30 p.m. regular class link only. I am going to take string handling. So that entire strings I am going to finish on that day. Okay. So that's why I request everyone to please attend. Then coming to double linked list. Uh, I will check it once. Ansari, I will check it once and I will update. Okay. So next term. So I need to implement the same thing, whatever we have covered for a single linked list. Same thing I want to implement for double linked list also. Let us implement all these methods related to the double linked list. Sir, here, see, double linked list means what? We have two types of what you can call nodes will be there. Okay, like in single linked list, how we have represented the node, if you remembered. So we have taken node in this style. Okay, we have only two fields will be there. So this first field is called as, so this first field is called as a data field, and this one second field is called as next field. Okay, this one is called as a data field and this one is called as next field, which is pointing to the next node. Sir, the same style will be there even for double linked list also. Okay, but in addition to that, we will have one more node here. So I think you people know very well about this node. Can you please tell me what is the name of this node, sir? Everyone, can you please, what is the name of this node? Yes, very good. It is nothing but a previous field. Okay. So we will have previous field. So here at the time of insertion, at the time of new node creation only, you have to concentrate on this. Okay. When you are performing insert operation and when you are performing delete operation, you have to concentrate about this new link. Except that rest of the programs, rest of the method implementation will become same. Okay, anyway, one by one I will explain with the help of program. Have a look once. Okay, so anyway, main method is there here. So what is the program that we have to take? A class DLL, double linked list. Sir, what fields are there in the double linked list? First I am going to take one special pointer called head, that is nothing but beginning of the node, and integer size is equal to 0. Like this we have. So integer size is equal to 0. Okay. Initially, how many elements are there? 0 elements are there. And I am taking class node. So this node will have three fields. One is nothing but data, next field, Okay, next field, and then node previous field. Three fields are there. So whenever we are creating a node, I'm going to send data for these three fields. So this dot data will become data, and this dot next will become next, and this dot previous will become previous node. Like this we have. And whenever a new node got created, I am incrementing the size. That's all. This is nothing but if you want to create a new node, how we are going to create. Okay, now void I want to take one more method called traverse. Okay, otherwise print. Okay, void traverse, let me take official name. So traverse, which is used to print that list. So we know very well, if head is equal to null, there is no more elements in this linked list. So we are going to print the message saying list is empty. Okay, then we have to terminate. Otherwise what we are doing, as usual, same code whatever we have implemented for single linked list, same. So current node I am taking. Okay, current node will become head. Okay, then while current node, okay, while current node is not equal to null, so what we have to do, system dot out dot println of, I will take only print. So current node dot data. Okay, then next node will be there. Like this I am taking. Then so current node will become, so current node dot next. Like this I have to take. Okay, so this is nothing but just like a normal display function only. At last I am going to take null. Now sir, let me create one simple object, double linker list. List is equal to, so new double linker list. So list dot I am going to use traverse function. Let us execute up to this and see what happens. Now you can see the list is empty. Now my requirement is I want to add the objects one by one. We know very well about the methods. So I want to add. Okay, but okay, let it be. So I will explain this function first of all. That is a traverse function, how it is going to work. Okay, so what is the logic that we have taken? Node current node, this is the logic, right? I will explain here itself. This is nothing but what we have. Now listen carefully, sir, how it is going to work. Consider I have a linked list is there. Okay, I have a linked list is there, double linked list. So how many nodes are there? Consider initially I have some three elements are there. I want to print these elements content. So this is nothing but a second node. This is nothing but a third node what we have. So this pointer is nothing but null, and this pointer is nothing but null. Its content is 11, its content is 22, and its content is 30. Like this we have. So this field next is nothing but this one. Okay, so this node next field is nothing but this one, and this node previous field is nothing but this one. Like this. So how many pointers they are going to maintain? Two pointers. This next node is nothing but this one. Okay, and this one previous field is nothing but this one. Like this we have. Okay, so what is the name of this field? This field name will become, so head node. Okay, this field name is nothing but head node. This is nothing but, so head node what we have, I am representing it as head. Okay, now sir, what is the logic that we have implemented? Current node is equal to head. So this node will become which node, sir? Current node. Sir, is it not equal to null? Yes, it is not equal to null. Print the data. What is the data that we have? 11. Next arrow mark. What about next one? Current node is equal to current node tends to next. Now this will become current node. So this will be gone. Okay. Sir, is it equal to null? No. Then current node data, which is nothing but 22. So what about next field? Current node is equal to current node tends to next. That means this will become your current node. This link will be gone. Sir, is it not equal to null? Yes, it is not equal to null. What is its data? 33. Then, so current node is equal to current tends to next. What is the next node? Sir, no node is there. So that's why current node will point to null. Here is there. Sir, current node is not equal to null. No, current node is null. So it will come out from this. If you observe here at the end, we have printed null. So it is going to print null. This is nothing but the output what we are getting for this. Okay. I think you people got a very clear clarity how this double linked list display function is going to work. Can you please confirm everyone? Is it clear? Everyone, please confirm. Is it clear?
Yes, sir.
Right. Now, so next term, I want to add the objects. Okay. So we know first one, we have to take, sir, 1 second, please wait. Yeah, sorry for the delay, sir. One emergency call. Now let us go with I want to implement a method which will take uh, adding the elements at first, sir. So which is going to take the data. Okay, which is going to take the data. So we have to insert this. Sir, what is the logic? We have to create a new node. Okay, new node of I'm going to take the data. Next field will become null. Previous field is also will become null. So if size is equal to 0, that means if there is no element, then your head will become new node. Suppose if the data is there, here we have to write the situation. Very, very important. Please listen carefully. If the data is there, then what will be the situation? Now listen. So here, consider initially there is no data. Initially there is no data. That means where my head is pointing, sir, my head is pointing to null initially. Okay, my head is pointing to null initially. This is nothing but so what we have at a very beginning. Okay, at the very beginning, this is nothing but the situation. Now I want to insert a node. Okay, I want to insert a node at the beginning, sir. Okay, let us see how you can insert. Now I want to insert node at the very beginning, sir. Let us see how you can able to insert this. So first I am going to create a new node. Okay, so first I am going to create a new node. This is nothing but a new node what I have. Okay, so which is having two fields. Consider the data is nothing but something like 33. This is the node which I want to insert. So once if you create a new node, what will happen? Okay, so what will happen? It is going to labeled with new node. It is going to labeled with new node. Sir, this will become new node. This will become new node. Okay, what is the name of this field? It is nothing but a new node. So initially, sir, is size is equal to 0? Yes, because we don't have any element. Size will become 0. Now what will happen? Your head will become new node. So once if you create new node, previous field is null, next field is also null. So hence this one will become which node? Head node. Okay, so head node and this node both are pointing to the same. So that means so single node got added. Sir, okay, fine. So that means we have a node is there. Okay, listen carefully. We have a node is there. This is nothing but node what we have. So here previous field is null, next field is also null. Okay, previous field is null, next field is also null, and the data is nothing but 33. Just for reference purpose we have used new node, but actually what is the name of this one? Which is nothing but a head node. So head node is pointing to this one, sir. Like this we have. Now, sir, already one node got inserted. I need to create one more node now. So what will happen? Anyway, add first, right? It will be added here. Okay, so it will be added here. Now, a new node will be created, and this is nothing but fields what we have. Okay, so this is nothing but fields what we have. And sir, what about references? Previous field is null, next field is null. Consider the data is 22. So what is the name of this node? Definitely it will be new node. Definitely this name will be new node. Like this I have node is there. Okay, like this one node we have. Okay, one second. Hello, hello. So next node here we have pointing to this new node, sir. Okay, new node is pointing like this. Now what we have to do here? So what is our next requirement? We have to link this. So in our previous single linked list, directly we have linked, but here that is not the case. Okay, we have to maintain two links here. What is the first link? Sir, this head node previous will become new node and new node next will become head node. These 2 pointers we have to write. Sir, what are those 2 pointers? So head dot previous will become new node. Okay, this is one pointer, and new node dot next field will become head. Sir, after that anyway we know that head will become new node. Like this we have to write these three instructions. Okay, sir, how the links are going to be changed? Now observe carefully. I am taking with the color. Head data previous, which is head, this one. So it's a previous node. Okay, it's a previous node is nothing but this one. So it's a previous node is nothing but this one. Okay, right? So what about the next one? New node tends to next. This is the new node, right? Next field is pointing to this head. Okay, like this we have. Sir, new node will become head will become new node. Sir, this new node from now onwards it will become head. Okay, from now onwards, so it will become head. Like this we have. Sir, what will be the updated list now? So updated list will become like this. Okay, updated list will become like this. So here we don't have this new node pointer. This will be gone. Okay, this will be gone. Like this we have, and this also will be gone. Like this we have, and this null is also will be removed, and this null also will be removed. That's all. This is nothing but what we have. So head is pointing to, okay, head is pointing to this particular node, sir. So I hope you people got very clear clarity how a new node will be inserted at the beginning. Sir, can you please confirm, do you have any doubts up to this? Everyone please confirm, any doubts up to this? So head dot previous will become new node. Okay, so new node dot next field will become head, and your head will become new node. Like this we have. Now I want to execute this code. Sir, initially the list is empty. So list dot add first of 333, list dot add first of 222. Okay, so list dot add first of 111. Like this we have. Let us execute this and cross check whether really those elements got added or not. You can see we are getting some null pointer exception. So because something is gone here, let us check what is that. 1 second, add first here. Next will become, so if head is equal to null, so where the problem is coming, in line number 34. Yeah, here we have the problem. Head is equal to new node. So head previous node will become new node. New node next will become head. Head will become new node. Correct only, right? So if size is equal to 0, head will become new node. What is the problem here? Integer data null. Return statement is not required because we have written else, right? Hmm. One sec. Hmm. Size node data next previous data next previous. Spelling is correct only, right? Size plus plus. If head is equal to integer data, so node new node is equal to new node of data null null. If size is equal to 0, head will become new node. Else, so head previous pointer will become new node next pointer will become head. Head is equal to new node. Correct only. Now what is happening here? Add first. At least we will check by keeping these two as a comments. At least one node is adding. Null pointer exception cannot assign a field because this dot head is null. So head is not at all pointing. So we are missing that head field, right? So thing is problem. Here itself we are getting the issue. Here already head is there, right? Let us see first case what will happen. Let us trace out when we are adding the first node. This will become so head is there. So it is a new node. So content is 22. This will become next, yeah, null, and this is nothing but what we have. New node is equal to this one if size is equal to 0. Initially head is not there, so size will become 0. Then this one will become head. Okay, now I want to add one more node, so let it be 11. Even that first one item is also not getting added. 11, so let it be new node. So already head is there, its previous node is equal to new node. New node tends to next will become head node. Now head will become new node. Pointers are correct only. Something it is not assigned properly. If head is equal to null, list is empty. Head is equal to new node, size plus plus. Somewhere the problem is coming. I will do one thing. I will put this as a comment. Let us execute now at least. So it is displaying list is empty, correctly working. But when we are adding one element, it is not get added. Cannot assign a field previous because this dot head is null. This dot head is null. Head node is properly not pointing. That is the problem. Current node is equal to head. Head. Hmm. First a new node will be created. Okay, suppose if size is equal to 0, that
No,
means
no, I think because we are creating the new node, so in the constructor, it will increment the size to 1. That's why head is equal to null because we haven't assigned it. So the new node has to be in the else statement or a little bit later down.
correct, correct. Who is that?
Vishal, sir.
Yeah, correct point. Hmm.
So we can change the code by saying if head equals null instead of size equals 0. And then in else, we can put the node new node.
Yeah, that is good, but I think we will do one thing. So here I will stop here and I will take this statement if size is equal to 0. So then we are going to create, so new node is equal to new node with this, and that will become here. Otherwise, so your new node will become like this. Let me check whether it is creating or not. Yeah, correct point, sir. Yeah, it is created. I think let me traverse, at least we are getting that 333 or not. Yes, perfect. Now let us work with this 222. Is it added at the beginning or not? Perfect. And now definitely it is going to work. So I think you people got a clarity. So how it is going to be added? The problem here is, sir, I have incremented size plus plus in this constructor. So when I am adding first, in the first line itself, I am creating a new node. So what will happen? Size will be incremented. If size is equal to 0, then only first node will be created. But this condition is false. Then it is trying to fetch the previous field of head. Head is null. So it is not possible, right? That is the problem what we are getting. Okay. Sir, then you can increment the size here itself, means yes, we can do, but there are some future problems are there. That's why I have written the code in constructor. Sir, I hope why this kind of error came and how we have resolved this, it is very clear for you people. Thanks to Vishal. Can you please confirm everyone clear up to this? Clear up to this? Please confirm everyone. Okay, right, right. Sir, I want to add the element at last. Okay, I want to add the element at last. How you can able to do? For example, if this is my node, okay, if this is my node, then I want to add the element at the ending. I want to add the element at the ending. Sir, what we have to do? We have to create a new node here. Okay, so we have to create a new node here, and so this node will become new node. Previous field is null, next field is also null. So consider this is nothing but null, this is nothing but null. This value will become something like 55. And what is the name of this node? New node. Sir, what we have to do? So if head is equal to pointing to something, then you have to make it as a current node. Is current node is equal to null? No. Is next field is not equal to null? Yes. Move this current node to next one. Sir, is current node is not equal to null, next field is null. That means what? We have reached to the end. Now what we have to do? So this current node next field is nothing but new node. Current node next field is nothing but new node. New node previous field is nothing but current node. That's all, right? So how you can able to write this code? Listen carefully. So first we have to take current node is equal to first node, that is nothing but head I am taking. Okay, so now next what we have to do? While, so current node dot next term, is not equal to null. Until it is not equal to null, so what we have to do? So here your current node will become, okay, your current node will become, so current node dot next, like this we have. Then at last, what is the current node next field? So current node next field will become your new node. Okay, then your new node previous field will become, your new node previous will become current. That's all. We have to insert this appropriately in our code, sir, then automatically it is going to work. Anyway, I will explain this coding part later. Sir, I think you people got very clear clarity how physically it is going to work. Can you please confirm any doubt up to this? Clear up to this? Right, sir. So I have another session is there. So I'm going to close this session. I will upload these running notes and images within few minutes. Okay. Right, sir. Thank you.